That's why we developed Ampros. And that's why we are where we are, because me and Stan from the very beginning both truly believe in this. We truly believe that today's world is changing, and it's changing on so many levels, and marine is part of this. It is happening now, and it will happen even more and more, and it's extremely interesting to be part of this.
Welcome to the 2.5 Conversations Connecting Innovators. My name is Klaus. I'm an innovation coach in Baden-Württemberg in the southwest of Germany. Innovators and creators from around the globe help each other by sharing highs and lows, their motivation and creative passions, as well as their favorite methods, tools, and ideas. The name of the podcast comes from the 2.5% innovators from Rogers' diffusion of innovation theory. Find more details, all the episodes and transcripts at the2.5.net. Enjoy the show. In this episode of the 2.5 Innovator podcast, my guest is Tomasz Gackoski. To say that he is very much into yachts and lightweight design is a bit of an understatement. We will be talking about electric boats. We will be talking about lightweight yachts. We will be talking about Sialia and Ampros. We will be talking about electric boats. Welcome, Tomasz. Great to have you here on the podcast.
Hello, Klaus. It's a really pleasure to be here with you.
Tomasz, what does silence mean for you?
It's a very interesting question. In general, because I love sailing. I started sailing at the lakes, and then I moved to sailing at the sea. And for me, silence, in terms of lack of a lot of noise around, because even if you're sailing, it means there's a wind. So there's always a bit of a noise from the wind, but it's being calm, going through the waves. And this is something that reminds me and always brings me to the moments in my life when I was doing sailing without noise or anything else. So this is silence that I was really used to all the time since I was like 13. And to me, silence today is kind of a luxury that not everybody is having these days.
Luxury? In what sense? Could you give me some extras, please?
Most of the people today, they live in cities. Most of the people in the world, at least in the Western countries, they live in cities. Cities are crowded. There is a lot of noise outside of houses. There is quite a lot of noise in offices. People are trying to insulate themselves from what is happening outside. And one of the reasons why people are going outside, so outdoor activities, going for sailing, spending time with family and friends, not in the clubbing, but as well at the nature, I believe that part of this is getting this silence experience. So without noises created by people.
I see what you mean. It can be very stressful to have lots of noise, and it can be very relaxing to have little or no noise, or maybe some special noise, some special music, maybe also that can be calming. But the absence of anything, I understand what you mean. I think we'll come back to silence later on again. But before we dive into what you're doing, we need to talk about your multifaceted background. You have done lots of things. You're involved in many things. You have a lot of interests also. Let's talk about that first, please. What is your educational background? What did you major in, for example?
I have education, which is aerospace engineer. I have 2 degrees in masters, one master from Warsaw University of Technology and Faculty of Power and Aeronautical Engineering. And second degree is master in advanced lightweight structures from Cranfield University in UK. So this is my formal background. Informal is that I'm passionate sailor, and I choose to go for these studies purely because I'm a passionate sailor and I love sailing. And when I was like 13, maybe 14, I decided that my future should be involved in engineering of sailing yachts.
Sailing yachts? Do you have an example? Is there any special yachts you have worked on or a special project?
Oh, of course. I can tell you my first project was during my doing my master thesis. I was designing 46-foot sailing boat. So you can imagine I never done any boat before. I was reading about them a lot. I read all the books, I a lot of papers, and on my last year of study, I had a contract to design a 46-foot sailing boat as a custom boat, and that was part of my thesis. When I got back from UK, I landed in Poland, and I was involved in execution of this. So I was building this 46-foot sailing boat with a team of people. Shortly later, I got a contact with Eugeniusz Moczydłowski, who is now my friend. He's a captain. And he asked me, Tomasz, can you design something like this? And he showed me a very famous boat, which is called Tara, for Arctic expeditions. And Eugeniusz, he asked me, can you design a boat that will go and circumnavigate in high latitudes? So when I was 26, I started designing extreme boat for sailing in Arctic Ocean during winter conditions with a lot of different appendages like lifting keel, removable rudder, a very special kind of steering equipment, and plenty other things. And during this project, I was consulting lifting keel design with one of my friends now, with Radek Michalik. And when I showed him what I've done, he said, it's a good design. Yeah, you figured this out very well. And he offered me a job to work with him in a company which still exists. It's called Structeam. And with Structeam, I started when I was like 26, maybe 27. And we've been working together for several years, designing and engineering really advanced sailing boats, wind turbine blades, and plenty of other things. And my first project that I was working with these guys was a 100-footer Wallicento, the first 100-footer under a Wallicento formula. And it was quite amazing because not always you start, and even I still know a lot of people who never been working on 100-footer, which is full carbon fiber, prepreg, really high-end advanced sailing boat.
Working on sailing boats is a special thing, especially when you work on these special builds. So it sounds also that you started very early with special stuff, and that put you on a path to make even more special boats and work on even more special boats, which had something at later point in common, that they got pretty lightweight, I suppose.
Yes, actually, the whole focus about being lightweight, it started with decision where to start my education, higher education. And I chose aerospace engineering because I have basically one goal was to work with most advanced sailing boats in the world. That was my original goal when I was starting my studies. And I had two options. One, to go to a place where I can learn a lot about sailing boats, a lot about ships, but very little about advanced materials. Or the second option, which I choose, is to learn a lot about aerospace and plenty of other things, because it was not only planes, rockets, but as well because of faculty in Poland, I was learning quite a lot as well about fluid dynamics, aerodynamics, and how to design some jet engines, gas turbines, a lot of stuff in general. And with this, I was able to touch this high-end technologies in terms of advanced materials, just lightweight structures made with carbon fiber, carbon epoxy composites. So that was my decision to go to aerospace engineering, which today is proving to be very good choice, especially with the latest development what's happening in the world, like foiling, advanced lightweight boats, something which today is being said, oh, it's a new technology and something great, and everybody is trying to say like how advanced this is. So this is what I was starting starting to do on my educational level.
I remember lots of boats that went on Lago Maggiore in Italy, that went on foils. There's some, I think, Russian examples also, but these are different foils. So there is lots of lightweight material, lots of electronics and stuff involved, sensors in this new design. Let's put it that way. Also, you were talking about wind turbine plates. I think that's something that is very important, doing lightweight. So I understand that this is very important for you to sort of maximize lightweight. Sounds weird. To minimize things, to make things great in a way. Is that something that you
Yes,
care a lot?
yes, I do care a lot about how we call it. It's a holistic approach, global optimization in general. So everything is working together, and all of this depends on the project scope. Because, like when you have wind turbine blades, not always about having the lightest, but as well you have other constraints like what is the cost, manufacturing times, and so on and so on. So there's more than just being on the edge. But I enjoy being involved in projects which are really, really on the edge. And when we are talking about marine projects, with because I was working as well with tidal blades, which works underwater at the depths, which is super challenging as well when you consider some project that works like 25, maybe 30 meters under the level of the sea. I was involved in some projects of underwater robots that were able to dive into 3 kilometers underwater as well, very challenging. And all of the projects that I was involved, they were always focused on something, and not always is just a pure weight, but sometimes weight and cost, weight and time manufacturing, weight and quality. Like when you have sports cars, something with visual carbon, for example, the quality, how it's done, sometimes it's driven not only on pure performance, but as well on aesthetics.
So you got a lot of different views on the topics we are talking about, working together with a lot of different people that also helped you to get different insights on these different topics. When you do such work, there is always different people involved, I guess.
Yes, this is in general, which is very, very much in line with my approach. My character is about team working. Team working not within one single company, but in general, team working in on the project levels. Project sometimes on the company level, if you call it a company as a project with your clients or suppliers. And I believe truly in this, that to have projects where your achievements in the end are exceptional, you need to have a good teamwork, good team spirit, people who are having the same values, the same goals, and are able to cooperate. Sometimes it means I'm not the smartest one in the room, even if I sometimes think that, okay, I know how to do this better, but maybe let's listen to other guys. Maybe they have something. Sometimes it's like really young people, 22 years old, and it's worth really listening to what their ideas are. Sometimes at the very beginning of the sentence, I already know that maybe this is not the best idea, but later I can find out that actually it's a great idea in the end of the day.
Mhm.
So cooperation and this work spirit within the teams, especially international teams, because this is my entire background. Is like I was working almost all the time with international teams. It's very, very important.
Innovation teams, the variety is the most important thing. I'm very much with you with its age, its different cultural backgrounds, and not just the knowledge that you bring with you. You said that people wanted to work with each other. I think that's a very important thing also that you have to bring to the table in such a team and be open to these other cultures. You're working in another partnership right now, and let's come back to the marine industry. In the summer, you have presented the Sialia Yacht, a very, very beautiful boat with a very special propulsion system. And I'd like to talk about that first because it's so obvious. It's because it's so pretty. It seems so special in a way. Please give us an idea what we are talking about right now.
First of all, thank you for these beautiful words, and very important for everyone who will be hearing this. You're hearing this because I have emotional connection with this project, with this boat. And I would say at the very beginning, because story how we achieved this, because it's not only me, it's entire team. And the story is, I believe, quite amazing. Because like a few years ago, I was doing some engineering for today my business partner for Stan. He was developing 60, in the end, 62-footer electric catamaran made with carbon fiber, and I was doing for him ultra high speed displacement hulls for a 62-footer carbon boat, catamaran, that was aiming to be like 30, 32 knots of top speed with given propulsion. And this is what I was doing. And there was a team of people doing quite a lot of stuff around. In the same time, Stan was developing a powerboat with other team that I was not aware of, but to use exactly the same, let's say, idea of propulsion. It was 2 times 250 kilowatts of power initially. And that time, one of the owners and founders of ICPT, so battery business, that is still exists. It was sold. It doesn't belong to Stan anymore. A battery business that is building heavy-duty lithium-ion batteries for a lot of applications. So again, great team of people who knows exactly how to electrify anything if you know exactly what you want to achieve. So during the project of Catamaran, there was a day when Stan took me on the side and said, "Okay, Tomasz, you're a smart guy. So what do you think about this?" And he showed me the project of the boat. So I looked at the numbers. I looked at this briefly and I told him, I think it's not really correct what you're doing here. He said, "Yeah, that's what I thought." And he asked me, "Can you do this better?" And we had a very, very nice conversation. And I told Stan, you know what? I'm not really a motorboat guy. I'm not going to design for you the best planning hull. Maybe I will be able to learn it, but then I will learn it and people will be asking me to design the planning house. Just not really my interest, but I can organize everything all together. And this is how we agreed with Stan. We agreed that I will be project manager of the entire project, and I will organize for him everything. So we've been looking for naval architects to do a proper hull design, a designer who in the end of the day is Denis Popov, one of my friends that I knew from the previous projects. And I knew that he's a fit exactly for this type of a project, open-minded and ready to hear some criticism as well. And we had a lot of proper discussions. And naval architecture, we went to Ripak from Netherlands, a really renewed naval architecture firm with a lot of experience. And we found a shipyard where to build it in carbon fiber. And I was responsible for doing carbon fiber engineering and management of the entire stuff. And on Stan's end, there was responsibility of organizing people to do entire propulsion system. So batteries, motors, and so on. So this is how it started. And based on this, everything has changed in between. I have learned a lot about batteries. I've done in between quite a few battery projects where I was doing this outside of the box thinking on and not only how to make it lightweight. This is another idea. So how to make next generation of the batteries, not the batteries that we have on the boat, but some other batteries, how to make them in a smart way, on the inexpensive way, including some thermal management. Because I had some experience from my university where I was having a lot of not only CFD but as well thermodynamics. So I was involved in development of lithium-ion batteries for Stan when there was such of a need during development of our Sialia in the same time. And in this way, I was able to spend a lot of time with system and software engineers responsible for development of lithium-ion batteries. I have learned a lot about lithium-ion batteries. During development of the project, I have learned a lot about systems, what is happening in behind the scenes and how it's done. And I become not only a manager of the project, but this is how we created Ampros based on this. And I become a manager and CEO of the entire organization, including software and system engineers, mechanical engineers, all of the people to create Sialia, to create excellent propulsion, and to be able to provide the solutions for other companies, other clients in the end of the day.
What an incredible personal development.
When I'm saying this, it was quite a lot of hard work, but as well something like willingness, because I was always eager to learn it. Why? Because I was so focused on development of the boat, and that was the moment where we had this entire holistic approach. Like I'm speaking to system engineers, and they're saying something about stuff, but like, yeah, but we can make it lighter. temperature of the cable is an issue. I said, yeah. So what is the temperature of the cable? And the guys were saying, in continuous it will be like 90 degrees. So it's too hot. I said, no, hold on. Doesn't mean that 90 degrees is too hot. I agree that it's hot. Let's see at which conditions we'll achieve 90 degrees. And the guys told me, yeah, but you told us that composite can withstand only like 65 or 80 degrees. I said, yes, but what is the cooperation between temperature of the cable and how much composite can withstand? We can cool it, we can put there a fan, we can put quite a lot of stuff. And I was diving so deeply inside that I have learned a lot on the system engineering. And the most important part is that I have learned how to implement this on a moving platform like boat, like Sialia, and how to make it work, which decisions are important. We've done extensive testing of the components as well. So we have done a lot of, let's say, tests during which we broke something intentionally.
And that's why you do the tests, right?
Yes, so we pushed quite a lot of stuff to the edge to break them and to see what really is possible and where some components will say no to us. We achieved this and we implement this in a boat. And when boat was doing sea trials, and first sea trials were done when boat was not finished, because what Stan has decided, and I agreed with him, is that we don't talk to anyone, we don't show to anyone what we do before the moment we both are confident that it works and it makes sense. So we started a project without saying to anyone we are the best in the world and this is what we want to achieve. We just did it.
Yeah, it's a very nice way to start something like that.
Yes, it is. It's opposite to what most of the people are doing today, especially in startup environment. But thanks to a huge experience of Stan, who is like 77 today, and he's in business for the last 50 years. He has experience and he knows how to handle complex and advanced technologically projects. We decided to do this in silence without a lot of noise around. Once we were sure that, okay, makes sense, we don't have really backups on hardware level, on the software level, because we were sailing with a lot of engineers on board to test not only if it works. This is, let's say, a relatively easy part for us having such a great team, but as well to see if it behaves, entire system behaves as designed, because this is another story. It's like you have something which is floating, okay, Archimedes law, nice, nothing special, but then to achieve proper speeds, proper powers, temperatures, and a lot of other things.
We will provide links to images and videos of what we're talking about in the show notes, because it's really worth having a look at the Sialia website, at these videos and see how it performs, how it looks. And I was really taken away by it when I saw it the first time. And it's such a great mixture also of a great boat for great experience on the water. It's great for a sleepover. It's a great thing to have guests on board and stuff like that. And it has a very, very special trick on the sleeves. No, like the propulsion is a very special trick, I think. And we need to talk about that also. But what I understand is that you sort of gradually, with a lot of hard work and lots of curiosity and the also you wanted to learn something. You wanted sort of to be part of good teams with a lot of specialists and to work with these people. You have evolved a lot in these past years into something that you might not have imagined, say, 15 years ago. So I think that's a really interesting personal development, which I like a lot also, which I think is important to have something like that. But then you work with all these great people and you can help them see things differently. I think that might be a speciality that you bring to the table also. And that's why you ended up with that great boat, which is sort of basically only in parentheses, a proof of concept for you. Let's put it that way, if I have understood this correctly.
And it's slightly more because during the development of this, when initially when we've been discussing with Stan on what is our goal, what do we want to do, was not really proof of the concept. we put the bar a bit higher because we wanted to do something which is exceptional and is usable. So it will be much cheaper for us to do aluminum hull and just go with power. But we decided to do something exceptional later because just propulsion is so expensive to develop, build, to have this hardware that it's not worth to have it on something which is not standing to the same level as it. That's why we decided to build 57 footer in carbon epoxy in carbon fiber, which is quite expensive technology as well, to keep it lightweight so we can achieve performance and to show to people as well that immobility on water doesn't mean that you always need to sacrifice your comfort. And comfort meaning, of course, you don't want to have a lot of noise. You always have a bit of a wind, water, and this kind of stuff. But as well to enjoy Sialia 57, just as you would enjoy all the other boats, even if they are not going super fast, even at the anchor, at the beautiful places at the Côte d'Azur, and so on and so on.
I understand that's much more than a proof of concept. It is something where you sort of flexed your muscles a lot and you wanted to achieve something really special to also show that it's possible and that it's a good way to go. Yeah.
Yes, I believe so. And going back 2 sentences before, when you're talking about personal development in general, today I am in completely different place than I was expecting. And one of very important learnings I have learned in general over recent years of work is that planning is only about, in the end of the day, choosing a proper path. Where you will end up, you don't know exactly. Hopefully, you will be somewhere around. But it's very important to see what is happening around and pick up occasions that are happening. The reason why I choose to do all of this, because I have not ended up like, okay, I'll do project management structure and that's all, because I was really eager to learn it. And I found it extremely interesting and meaningful to be involved in such a project on a higher level. That's why we developed Ampros. And that's why we are where we are, because me and Stan from the very beginning both truly believe in this. We truly believe that today's world is changing and it's changing on so many levels. And marine is part of this. It is happening now, and it will happen even more and more. And it's extremely interesting to be part of this.
In cars, I think we have to get to that point right now. In cars, it's very common already to have electric propulsion in the marine industry. There is some cases where it's been around for a long time in different contexts, but it's not normal. It's not widespread used to have an electric propulsion system. And you are working on that with Ampros, with your company Ampros, and you have shown how that works in the Sialia 57.
Yes, cars, it's a very interesting part because obviously one of the strongest points of Ampros is that we have a great team of really great people, not only engineers, but general entire team. Is just amazing how we are all working together and we are able to achieve the highest possible goals. So we know quite a lot of stuff on e-mobility in cars as well, heavy duty industries as well. So we have all of this knowledge in our hands just here. It is here. This is one of the biggest difference between us and some other people that are trying to do electrification is that I'm coming from marine and lightweight structures and so on. But most of the people in our team on technical side on e-mobility, they are coming from automotive, which is bringing to us a lot of knowledge because automotive on water has already like 20 years. For example, my business partner, Stan, he has done the first fully certified in European Union electric car. And it was before Tesla was done in US. He has done this. And he was doing this with some of the people that we work together with. And they were developing electric motors, electric converters, batteries, and so on. So we have a lot of knowledge and the history, how it happened, why it's done like that. We know what is not easy and where to get it. And we're getting a lot of these things from e-mobility. A lot of let's say, projects that have failed over last years in marine, because there are some of this, it's because people, when they were going from marine, from low voltage applications going into higher voltage, they did not have this luxury of experience as we have with people from automotive, and especially from automotive with background. Because as well, I can tell you, there are some modern cars quite recently developed with people who have learned something on them. And they were, for example, using some rules from microwaves, Why? Because they did not know that there are other regulations as well to do this. So the reality of e-mobility, it's a very, very young niche. And even on the cars, it's still very young.
Mm.
But thankfully, because it's growing and growing and growing, the amount of knowledge that you can get on the cars is just amazing.
And the quality that you get used to is there and can be transferred in a way also to the marine sector, where you are creating electromobility on the water with that group of people that you're working together with at Ampros.
Correct, but there are differences. The difference between, because automotive is a wide sector, and we have, that's why we call heavy duty applications, like public transport. It's a good example, because boats, even pleasure boats, are kind of a heavy duty applications. Because when you imagine on a normal electric car is driving 100 kilometers per hour on autobahn, on the highway. In cities, you do like 30, maybe 50, which is corresponding to power that you have on wheels. Power that you have on wheels in typical, it's something in peaks. RMS will be 10, maybe 15 kilowatts in city. On the highway, you'll get around 20 kilowatts. So this is your continuous power that you're normally driving. When you're looking at the boat, Sialia is doing at 16 around 400 kilowatts, which is like 20 times more than you have on a normal car. At full speed, we can achieve 1 megawatt of power, and we can safely disconnect this. So this is power that is similar to like a train, basically. This is the range of powers that we're talking about.
You need
So
big
when we're
cables and big whatever, just everything needs to be highly secure also.
You need to be aware of what you are doing, I would say, at the very beginning. See what is the mission and for how long you use it, and make it work. But it's not really one to one. You get stuff from personal car to boat, and it will work. This is very important, because sometimes people who are using electric boats, they can be very surprised. If you have a car, you have a boat with a car application, everything all together, you can be surprised, because if system for the car is designed for continuous operation at 20 kilowatts and peaks of, I don't know, 60, 100, 150 kilowatts, peak is not the same as continuous. On peak, and this is one of the, let's say, misunderstanding that is commonly being shown when somebody is entering immobility on water, is power 400 kilowatts. It's a peak power for 15 seconds. What is the sense of having 15 seconds of peak power on the boat? Like there's no sense. You should be always thinking about continuous power that you can achieve, because this is the scale that we use in marine applications.
You sort of learned about the quality and about things and about the questions to ask from electric cars. But then you also knew from the development on the heavy duty vehicles about the challenges if you have to deal with the high voltage or whatever that is involved. I'm not an electrician, so I don't know anything about that. So many things fell into the right place to make Ampros possible.
Yes, in general, we are a huge group of interdisciplinary knowledge, and it's a must, in my opinion, to be in this market. This market, I mean marine, because marine is about making a little bit of a serial production boats, but quite a lot of interesting projects are one-offs, which in the automotive world, it will be prototype. When you look at cars like Bugatti Chiron, this is one of my favorite examples. They built like 500 of cars of these, but before it was built, they've done 8 prototypes. In marine, in most of the cases, you do 0 prototypes, and your first boat is your hull number 1. It's not a prototype; it's a boat which is ready for the end client. And quite often, on bigger boats, especially, it's only hull 1. Nobody is doing another one because end client is wishing, I want something more special or just different.
I see what you mean. There's a lot of players out there, lots of shipyards that might be specialized in maybe materials or some designs or sizes of boats. And some of them might have a line, a factory, like Bavaria or Beneteau or all these big ones. But basically, most of the other shipyards do one-offs or maybe very, very small production numbers. So that's where you also come in with Ampros, as I understand this correctly, because what you do is you provide them with the engineering, but also with the technology for propulsion, for electric propulsion in these boats, right? Because they wouldn't have all the knowledge in their shipyard themselves,
Yes,
because they're way too small. But that's where you also come in.
yes, that's why we exist. It's to provide entire propulsion systems for the end client for the boats, and this is always done in a shipyard. And so we are involved at the moment in, let's say, on the segmentation level. We are positioned on mid to big boat market. Mid, which means smallest that we are aiming for, and smallest project that we are doing at the moment is 45 footer, and the biggest project that we are doing at the moment is 45 meter. So this is the range that we are doing. When you look at smaller boats, which is outside of our segment, we don't provide small motors. Small motors in terms of power, it's just one part, but I would say equally important is energy storage systems, so batteries. We don't provide something with very small batteries. Like when you have a typical jet ski has a powerful motor, but battery is like 23, maybe 25 kilowatt hour. High performance battery, but very small. On Sialia, the minimum that we have is 250 kilowatt hours. The maximum that we get is 1000 kilowatt hours. When you look at boats which are 6-7 meters, and this is the most lucrative market from, let's say, investment point of view, because all reports are showing that this is the most popular size in the world. And in this segment, you're looking at batteries which are 50, maybe 60 kilowatt hours in terms of capacity, which is relatively low. And it's too low for us. And there's quite a lot of competition at the moment.
But that also means that what you can do, you don't need to have in such a small boat. It's not just about the size of the battery. It's just not
Mm,
required.
I would say it's a questionable if it's required or not. Uh, um, in the end of the day, market is telling you if this is okay or not.
Mm,
But what we provide, yes, we provide higher power solutions.
yes.
And as well, when you go into bigger boats, and this is challenge with yacht boat is that it's not only propulsion. In the end of the day, you have as well all the hotel loads. It's like floating house with propulsion. And all of this needs to be combined. At the moment, the biggest segment that is growing, I would say, are big solar catamarans with a lot of solar roof, and they don't require a lot of power just to move, but they require a lot of power for hotel loads,
Mm.
for AC and for everything else to have a silent operation.
And lots of integration of different systems also.
Yes, a lot of systems being integrated in the same time, and being careful how to manage all of this so it works. Number one, then it works for the long periods of time and works in maintenance free way. In the same time, another good segment of boats, which is getting like super popular, I would say, is on the sailing boats. When you do electric propulsion, you have ability to regenerate power and store it in your onboard energy storage system.
Yeah, that is a great thing. And I really don't understand why people don't add more electric propulsion systems to sailboats. But okay, that's another thing. What I also understand is that once you start to integrate so many systems, there is a lot of work to be done in the software control computer side. And this is also what you do at Ampros. You don't just talk about electricity, about motors or batteries. You talk about the whole software and the control systems also.
This is the base. Let's say reality is that from hardware point of view, it's relatively easy to calculate what should be the section of the of your wire, what should be the connection. Some people who are selling you wires will tell you, or cables, they will tell you what to do, connectors, all of this exists, and you can buy it. You can buy electric motor, you can buy a battery, and you can get it. But to integrate this and to be sure that all of this is working in the same time in all conditions, this is the challenge. Because in the end of the day, on Sialia, I think at the moment we have like 8 different CAN bus lines. They all are loaded. Yes, that's a lot of data that is floating around. We have more than 3,000 different parameters in the system, and all of them are important and required to be there. So everything is working in a seamless way. Like you want to leave the boat in a marina, but you want to switch it off. But in the same time, but I would like to have an internet connection with it.
Yeah.
I would like bilge pumps to work there. Actually, I'm kind of like to have ice maker being on, or at least fridges. And yeah, it will be nice actually from time to time to turn on ventilation inside. And maybe when I'm arriving on the next day, I would like to remotely turn on my AC. So boat is ready for me. And if actually I don't have short connection because somebody has plugged this off, I would like not to discharge completely my batteries and so on and so on. So
Hmm.
the amount of, how we call it, user scenarios, just enormous on the bigger boats where you have more things you can do. And we need to be prepared, and we are, for stupid approaches sometimes. And we already checked this. People sometimes do stupid things. So you can have on one room turn on AC, on the other room you can accidentally turn on heating, or kids can do this. So we need to be prepared for this. And if you have a boat in marina, you need to have everything working, but propulsion not to work. Uh, so we need to have a notification system, and so on and so on. So in the end of the day, in Ampros, most of the staff is on engineering level are system and software engineers. All of them work on computers, and all of them are working on proper algorithms. And in the end of the day, we do software, then we do testing of the software, then we do implementation of the code.
I had to think of also stabilizer fins or the gyro stabilizers and all the trim tabs and stuff like that. There is so much on a, especially on a large boat, that needs to be integrated. Is there some sort of uh, data exchange standard that allows all of these systems together to speak with each other, or is that something that you have to, that challenges you also?
It is a challenge. In general, on this typical stuff, you have an EMEA 2000 protocol, so they talk to each other on this protocol. But we use other protocols as well, because some components, they're coming from automotive, so they have different protocols and so on. So we used, I think 5 or 6 different protocols of communication in between. So we have a lot of CAN buses, a lot of just in digital and analog input outputs, because we need to control not only sophisticated components like inverter. We have very sophisticated, the most advanced inverters you can imagine. They require like 70 parameters just to turn them on, even if you just want to spin your propeller, but there's a lot of data. But as well, we have super extended system of measuring things and acting. We have separated safety system that is checking, do we lose isolation of the system? If we lose, then what do we do? And how to check it? Temperatures. We have around 190 temperature sensors on the boat regards to the propulsion. We have fire extinguisher system as well. We have humidity sensors, and so on and so on. So the amount of things that we have on board, amount of data that we need to collect. Maybe it's not like we need to. Maybe not everything is necessary. It's still a
Mm.
young boat. Maybe after 10 years of exploitation, we'll figure out that actually half of this is not needed. But for the time being, when we have such an example of a boat, we put a lot of sensors and we get a lot of data.
Yes.
And we do write a lot of algorithms that are acting, flow sensors for seawater, sensors if what happens if we are losing. So your intake is clutched, then what you do and how you act. Maybe sometimes you need to decrease the power, what you do if your seawater is too hot. This year, boat was in Côte d'Azur. The maximum water temperature was around 30 degrees, which is already quite hot. We have additional AC units to chill down batteries as well and battery room, but it was quite hot. So we need to act with this, and we need to check if we were unable actually to check this. What will happen if we will have 37 degrees of seawater? Uh, but in Florida this year there was like 37 Celsius degrees, and even motorboats have had some problems.
Yeah.
So we have this type of sensors, and we have algorithms what to do with this, how to not to destroy the boat, and in some cases uh, you need to decrease available power for the end user to prevent damage.
You put in all this thinking and work for all these special systems that in the end creates an experience for the user that is basically without any troubles, any worries, right? It's something that the user can go on the boat and use it in a very simple way, even with such a high complexity in systems
Yes,
altogether. So what you create is a very fine experience on the water, which is silent. Basically, right? There's always waves, there's
correct.
wind, there might be some mechanical noise depending on your speed and stuff like that. But basically, we're talking about a silent experience on the water in a powered boat without sails.
Yes, I would say, just a bit elaborating what you just said. First sentence that Stan has told me when we were developing the stuff, Tomasz, we need to have idiot-proof system. People are not reading manuals. They don't really care. They don't have time. If somebody wants to use the boat, they just get on and they go. Just as simple as that. Stan is a pilot, so he knows there's a checklist on the airplane, and if you spend some time on the boat, we have similar things to be checked, but our aim is to decrease the amount of checklist, amount of thing that you do, and most of the time, all the new captains they don't do nothing, you know. And to achieve this kind of a level of system requires complexity behind. How to make the system idiot proof means engineers need to think about different scenarios, different cases, and implement this into the boat to achieve in the end something which is easy to use and as additional it's electric and it's silent. Yes, exactly. It's when we were doing this year some of the tests with journalists, and they were doing tests of the noise, even because Sialia is equipped with range extender, diesel based range extender, which is it's a noisy stuff, but it's a must for the time being. But we have an option to convert this boat to pure electric, remove it and put more batteries. So we were checking the noise levels even with generator on, and we were the most silent electric boat as well on the market because we simply put a lot of care on using additional insulation sound materials even for the generator.
So you sort of in a way back to your beginning, right? Silence is very important. You put very much effort on the part of the silence, and you probably will continue working on that. You just talked about removing the range extender, which will remove noise also, or vibrations, I suppose. How does that make you feel that you have a boat that has a quality of a sailboat, a quality of a sailboat, right? It's not, I understand it's not fully comparable, but it's very practical and basically everybody can use it.
How I
Just
feel it, it's excellent. It's excellent. Basically, we achieved the goal that we wanted to achieve, making this boat, and in the end or in between, creating Ampros of this. Very important to understand is that I do all of this because I love sailing, and I'm in Ampros and Sialia. only because these boats are electric, only because of this. If it will be like somebody will tell me, Tomasz, let's make an idea of the fastest, boat ever. Maybe on engineering level to do composite, it will be interesting, but I would never be involved full time like I am with Sialia and in Ampros, simply because I don't believe in this long term on making noisy, smelly stuff on water. I know it's fun. It is fun. It's a lot of fun. Simply not for me. And I'm absolutely aligned with immobility on water on electric boats, which are silent and can be performing well as well.
Basically switching everything else that used to be gas powered to electric propulsion in cars, in boats. It's happening in big ships over time. It will happen somehow, possibly in airplanes. There is drone type of helicopters that are powered electrically. There's lots of development in every industry, I suppose. We see a switch from Formula One to Formula E, for example. I see that it's not happening right now, but there is things happening. What do you see happening in your industry, in the marine industry, and what is important to happen to sort of accelerate the development?
So on the water, it's number one. I would say it's a charging infrastructure in general. We have some projects where we have as well hydrogen and methanol on board, and some sophisticated ways of charging infrastructure. But charging is the number one. Nobody will buy a boat which they cannot charge. That's why at the moment on Sialia we have range extender, because simply there is not enough places where is sufficient infrastructure to do charging, especially on the bigger boats. So this is number one that I would say. There are some people who are now looking for boats, but they don't exist. Sialia, if you look at the market, is the biggest electric boat available on the market. There's nothing bigger at the moment. Current range of boats is ending around 35 foot. 30, maybe some of the ribs are 40 in Norway, but in general, it's around 35. If somebody has a need to have something bigger, like go sailing not with 4, but with 6, 7 people, do slightly longer distance, do sailing in slightly rougher conditions, and there is a limited available solutions of boats. That's one of the reasons why you have Sialia, which is 57, or the next models are 59, and another one that we are working at the moment is 45. To have something which is slightly bigger for other people. So this is another limitation. People will start buying electric boats when they will be available. At the moment, you have some pointing applications, you have some smaller boats, and we're getting there with bigger boats as well.
Most of these bigger boats are catamarans with electric propulsion. Some of them rely on solar power also. Some might have a range extender added to it. But a catamaran is a completely different category with so much more space, hull space or deck space or roof space for solar panels. Plus, they have the hull is basically more efficient than another type of hull. So, what's your plan with Ampros? Would you push for larger sizes of boats to implement your systems, or where would you go? Where would you head?
At the moment, the biggest opportunities, I would say, are at the boats on size around 40, 45. This is the size, but higher performance, higher ranges, higher speeds. This is what people would like to have. So this is one segment that I see will be more mass produced. Second segment is big sailing yachts, like 35, 40, 45, where people have sufficient budgets to do electrifications. And when you have a sailing boat, because on bigger, especially on the bigger sailing boats, especially on racing bigger boats, like not everybody is fully aware of the fact that on 80, 90, 100 footers, there's continuously running diesel motor to provide power for hydraulics. Even if it looks like it's a nice boat, yeah, it's a nice boat and silent. No, not really, because diesel is always running, and not everybody is fully aware of this. And this is the place where electrification is coming. Till the moment when still diesel is allowed, it's lighter. but battery systems and electrification is getting there. And this is what I see from the request for quotations. I would say it's most of them are actually from very big 40, 45, 60-meter sailing boats where owners are conscious about sustainability, about environment. Most of them would like to go on the circumnavigation. They would like to go around Cape Horn and go around Antarctica and so on. And these are the places where you really would like to be silent. You really would like not to burn a lot of diesel. You really would like to use this energy from wind, which you use for the propulsion, to use it as well to create energy on board, and then use this energy for all the hotel loads. There is a great project which is called Project Zero in Netherlands, designed and developed entirely by Vripak. I think it should be on the water like next year, and they put a high bar and the level on putting boat which is like zero carbon footprint during operations. This is something that is happening at the moment. And a lot of owners of boats are looking at this project as well, and they are asking us, can we actually provide solution for their projects?
Once you have seen that it's basically possible to have a very, very low or maybe zero carbon footprint on a boat, I think you can't go back. It's just it is in your head. It's in your consciousness, and you have to strive for it. If especially if you do something very special as you just mentioned.
It's one way. It is absolutely only one way. One of the things that mm, not everybody is fully aware of, but let's say before Met, like a few days ago, last week, I was on the pre-thinking night 3-pack event, our naval architects in Netherlands before Met, when there was quite a few interesting presentations from different people. And there was a PR manager from Petship, one of the biggest, most luxury shipyards in the world at the moment. And I had some discussion with him after on who is current clients, what people are doing, and what's happening. And not everybody is fully aware of, but new countries like BRICS, Brazil, India, China, this kind of a country with new wealth and younger generation of people, younger generation that will be owners of future boats. They're getting there now. They have completely different mindset than people before. And this is changing at the moment. They are more and more conscious about this. People are really getting more and more focus on being sustainable with less, not only carbon emissions, general emissions, because what we are forgetting it's emissions. It's not only carbon. Even if you, my good example is when you have hydrogen. For me, my personally, the best option is to use fuel cells because then it's completely no emissions. But you have options to do combustion engines with hydrogen, but you forget that you still have other things that is in the air and pollution that is getting out of this. Either you have additional filters, or you have this kind of a pollution which can happen. So I would be focused on putting not only zero carbon footprint, but in general reducing pollution from other sources as well.
Mhm.
And the world is changing today, and there is only one way. Today, people who have bought electric cars, uh, very little of them is considering, oh, it's not for me. Let's go back to my old Corvette, Ford Mustang, or whatever. It's not like that. They're rather thinking, if they're not happy with this, that, yeah, maybe I should have a better electric car, which is new today, not the 3-year-old one.
I'm with you. Tomasz, we have heard that you worked in lots of contacts with lots of people, lots of different teams, many different projects, and there was a gradual development in your skills, in your interests, also in the context that you can operate. Um, Looking back, what do you do best? What do you think is the things that you like to do best or you are best at?
This is very good question, I must say. I was not expecting that. For me, I believe that my best is working on the first rule principles and doing quick estimates where I can do like 80% of a success within this 20% of time. This is where I'm feeling very confident with at beginning of the projects and this kind of a judgment. So this will be number one thing for me, which I'm finding. And number 2 and 3 will be really leveraging skills of people that are within the team. This is part of the job, part of the skills that I have developed over the last 2 years when I work with group people is how to enforce them to bring the best out of them in a project context.
Thank you very much for taking the time for our conversation today.
Thank you very much, Klaus.
Thank you for listening to the 2.5 Conversations Connecting Innovators. You can subscribe to the show wherever you get your podcasts. A transcript of this episode and additional information is also available. The link is in the show notes. My name is Klaus. I'm an innovation coach in Baden-Württemberg in the southwest of Germany. This is the 2.5.